Ozonolysis of an alkene. So this reaction starts with an alkene, and we can see as the product that we have two carbonyl compounds. So this reaction, ozonolysis of an alkene, is also known as an oxidative cleavage of an alkene because we are both oxidizing these two carbon atoms and we are cleaving the bond between them. So we will form carbonyl compounds, either aldehydes or ketones, depending on what these bonds are. So aldehydes or ketones. So this is a two-step reaction. The mechanism is well understood. It is also quite long and one that you would probably end up learning by rote memorization. So I am not going to hold you responsible for this mechanism. I am going to show you what the two-step process is and what the intermediate is. So in the first step, ozone is added at a low temperature, and the intermediate product that we get looks like this. So we've got this 5-membered ring, and this is known as an ozonide. Ozonides are not isolated, they are explosive. So we don't isolate these. We would immediately go to the second step. So first step, ozone at a low temperature. After the ozonide forms, immediately we would add in either dimethyl sulfide or zinc metal and acetic acid, and this would break open this ozonide to give the two different carbonyl compounds. So you do not need to know the mechanism for this reaction. And you don't actually need to know the structure of that ozonide either. You just need to be able to go from the alkene to the carbonyl products. So do not need to know the mechanism. Okay. So the easiest way to predict the product of an ozonolysis is to solve the reaction using a pencil. So I am going to draw an alkene. So there's my alkene. Put the two-step process up. So ozone at low temperature, followed by the second step, and I am going to choose the dimethyl sulfide. So the easy way to draw this product is to actually redraw the starting material and just draw this double bond a little bit longer. So I'm going to exaggerate that double bond and make it longer. And in this reaction, I am going to cleave the double bond. So here I am going to cleave the double bond. So that's the cleavage part, oxidative because we're adding two oxygens. And so if I want to draw those products to make them look a little bit better, I can see that I have a 1, 2, 3 carbon atom aldehyde, and I have a 1, 2, 3 carbon atom ketone. And those would be the products from the oxidative cleavage of this alkene.